Hello and welcome to Casual Learning. I'm your host, John Bannon. Today I'm going to do a review of chapter 17 of my newest book, God and Our Superdeterministic Universe, the number one argument for the existence of God. This book is available on Amazon Kindle. Chapter 17 is entitled, Matter Need Not Always Exist. One might be inclined to think that today exists because yesterday existed. And then one could say yesterday existed because the day before yesterday existed. So one could logically conclude that because today exists, yesterday must have existed. And because yesterday existed, then the day before yesterday existed. Because the day before yesterday existed, then the day before yesterday must have existed. And so on and so on and so on, regressing infinitely back in time, thus concluding that for today to exist, there must have been an infinite number of prior days that have existed in the past. That logic leads to the idea that the universe is eternal. That is, it has always existed. And if the universe has always existed, then matter and energy will have always existed because that's what the universe is made of. Um, from that, you could say, well, since matter and energy has always existed, then you don't need a God to create matter and energy because it's always existed. So, what do you need a God for? Um, However, there's a central flaw in this argument. And the flaw is that Dr. Hansen, under his version of superdeterminism, proved that temporal causation or continuous causation in physics is not real. Um, what that means is that yesterday did not actually cause today. And the day before yesterday did not actually cause yesterday. And the day before yesterday did not actually cause the day before yesterday. Therefore, without temporal causation, this whole argument that the universe must have always existed based on the fact that today exists falls apart. There's no actual causation going on. So there's no need that um, that the universe has always existed. Uh, there isn't this continuous causation which suggests that the universe has always existed. So, without that temporal causation, that metaphysical, continual, causative force of nature, then there's no reason to believe that the universe must have always existed. I mean, if you think about a metaphysical, continuous causal force of nature, which many equate with the laws of physics, it doesn't appear to have an on off switch of any sort. So it doesn't appear to have the ability to be turned on or turned off. So the natural assumption would be that it's always been on, it's always existed because it presently is in existence. Except that without temporal causation, this metaphysical, continuous, causative force of nature is not real. It can't be because it can't cause anything to happen because temporal causation is not real. So why would you believe in it if it doesn't cause something to make you believe it's real? So, um, therefore, there is no reason to believe that matter and energy in the universe has always existed. Some people may cite the principle of conservation of energy and mass and claim, aha, under that principle of physics, energy and mass cannot be created nor destroyed, but simply transformed. Therefore, it must have always existed. Well, that's not quite true. The laws of physics, specifically the principle of conservation of energy and mass, being part of the laws of physics, breaks down at the Big Bang. We don't know what the laws of physics were at the Big Bang, if any. But because of the breakdown in the laws of physics, the principle of conservation of energy and mass doesn't apply. So that principle of conservation of energy and mass does not strictly oppose the creation of physical reality or energy and mass at the Big Bang or at the first existence of the universe. Um, a static block reality without continuous causation in physics can also explain the conservation of energy and mass as a result of the sharing of information between hyperplanes of space-time in this tight-knit block reality, static block reality. The general gradual change in appearance from a budding hyperplane to a budding hyperplane caused by the sharing of information in a tight-knit block reality causes the generally strict deterministic physics that we see in the universe. As a result, all the energy and mass of the universe in the present moment must be equal to the energy and mass of the universe in a future moment, because both moments appear to cause and retrocause each other as a result of the strictly deterministic physics in a static block reality without temporal causation under superdeterminism. The appearance of new energy or mass, or disappearance of energy or mass, cannot appear to be caused or retrocaused by nothing under strictly deterministic physics. And therefore, the same amount of energy and mass appears to be always conserved. So, because our universe is a static block reality without temporal causation, and it generally appears strictly deterministic, um, that appearance of order in the static block reality between the abutting hyperplanes of spacetime can account for the principle of conservation of energy and mass. Um, if you think about the static block reality as this sort of tight knit intersection of abutting hyperplanes of spacetime that share common information, and that's what allows them to coexist with one another, creating the universe or allowing the universe to exist. Um, Another thing that tells us that the universe hasn't always existed, um, but was created, is the appearance of pure randomness at the quantum level, as evidenced by violations of the Legec-Garg inequality. Um, and what this indicates is that microrealism isn't the fundamental nature of reality at the quantum level, such that one should insist that an object exists independently of the hyperplanes of spacetime in which it appears, and that therefore this independent existence of this object must be preserved. That would be microrealism. So in microrealism, this pen is a pen. It's got an independent existence of itself, and therefore it must always be accounted for in the hyperplanes of space-time. That's microrealism. But at the quantum level, um, microrealism isn't the case. Rather, it's pure randomness. And because the quantum level is more fundamental than the macro macroscopic level, then even this pen isn't actually a macro realistic object. It only appears to be that way, but it doesn't really have an existence independent of its appearance in abutting hyperplanes of spacetime in the manifold, in the local area surrounding the actual appearance of this object. So, macro realism. Imagine that you have a penny, a nickel, a dime, and a quarter. All right, these are macro realistic objects. As macro realistic objects, let's say you wanted to reorder them in a different sequence of appearance. Instead, you wanted a dime, a penny, a quarter, and a nickel. All right. So you wanted to change the ordering of these macro realistic objects to be like this. So in order to do that, you would have to move these coins around in order to rearrange them to appear in this order. So for instance, if you wanted to move the penny over to this position, you'd have to move it over one to the right. And if you wanted to move the nickel all the way to the end, you have to move it to the right two spaces. And if you wanted to move the dime all the way up to the front, you're going to have to move it two spaces to the left. And if you want to move the quarter to the third spot, you're going to have to move it one space to the left. So all those motions are going to have to occur, those sequence of motions, in order to get the new ordering that you want. That means for macro-realistic objects, the hyperplanes of space-time have to include all the movements that must occur in order to rearrange these macro-realistic objects into a new ordering. Well, pure randomness at the quantum level doesn't work like that. The violations of the Legge-Garg inequality prove that the quantum level is not macro-realistic. So what does that mean? Well, what that means is at the quantum level, you could go from an ordering like this, penny, nickel, dime, quarter, to the next ordering, this, purely randomly. It simply purely randomly appears without all these movements that a macro realistic object would require in order to rearrange themselves into a new random order. So the quantum level is not macro realistic, it's purely random. Um, Pure randomness at the quantum level allows the reordering to appear without the movements, uh, provided it's not under constant observation or measurement. So, if there's no temporal causation, because Dr. Hansen proved temporal causation is not real, that means you can't do these movements um, at the quantum level because they're not macro realistic objects. So how is it that you get from here to there when there are no intervening movements? Um, well, this suggests that there has to be something I call non-temporal causation. So something has, so you're at the quantum level and you see this arrangement and then you see this arrangement, but you don't see all these movements occurring in order to get into this arrangement. So how do you explain going from this arrangement to this purely random arrangement? How does that happen? If there's no temporal causation, there isn't any. So it's not that this is being caused to turn into this through these movements, because temporal causation is not real. So how does this happen? Um, you could say, well, it just pops into existence, right? But because temporal causation is not real, then there is no metaphysical continuous causal force in physics that could simply pop this into existence. So, how do you explain its existence if you can't explain it in terms of this reordering? And you can't explain it as simply popping into existence at that particular moment in time because temporal causation isn't real. So, how does this happen? Well, it clearly has to be caused to happen. There's got to be some way to explain how this becomes this. And the only explanation is non temporal causation. It is caused to exist outside of time when the predetermined universe itself is caused to exist as a static block reality outside of time. So the pure randomness that appears at the quantum level is evidence of the existence of non-temporal causation. So if there's non-temporal causation, then physical reality does not always exist. Even timeless physical reality, such as hyperplanes of space-time, do not always exist. They are non-temporally created, which simply means that a timeless physical reality can either exist or not exist. And its creation is outside of time. It's not a temporal creation. So if it exists, it's been non-temporally caused to exist outside of time. And it can also be removed from existence. So that would also be outside of time if it was removed from existence. But because a timeless physical reality can either exist or not exist, then there has to be non-temporal causation. How else are you going to explain the existence of our universe out of 1 out of 10 to the 10 to 123 other possible permutations of our universe? How come we're so lucky and all these other universes weren't? There's no continuous causal force of nature, some sort of metaphysical continuous causative force of nature, such that our universe just happens to be unique because it's being caused every moment of time to exist. Therefore, somebody's got to win this lottery, and it happens to be us under this continuous causal force of nature. But that metaphysical continuous causal force of nature doesn't exist. It's not real. Dr. Hansen proved that because temporal causation is not real. Therefore, this metaphysical causative force of nature is not real. Therefore, that can't be used to explain how come we exist and these don't. What explains it? Non-temporal causation of our particular universe out of all these possible that don't exist. Now, there's no scientific proof that any of these other universes exist. And it's very unlikely there ever will be any proof that a single other universe exists, let alone this number of other universes. For simple reasons that you can't travel faster than the speed of light. So you'd never be able to travel far enough to even find another universe. You couldn't leave our universe in order to pop into another universe. universe to prove it's there, because that would make your mass and energy disappear from this universe, which is a violation of the principle of conservation of energy and mass. Um, and you could never see another universe because it's beyond the cosmological horizon. There's a limit to how far we can see out the universe, depending on the light. Has the light had enough time to travel to Earth from a great distance? There's a limit to how far we can see out into the universe. You can't see any farther. It's impossible. Light hasn't had a chance to get here yet. So you can never prove another universe exists from the light coming from that universe to our universe, because it would be beyond the cosmological horizon, and it would never have enough time for you to see it. So, for all intents and purposes, a multiverse or an almost infinite multiverse or an infinite multiverse are pure science fiction. You can't prove the existence of those things. It's pure science fiction. So that that shows that non-temporal causation is the only thing we have actual scientific evidence for, and it's needed to explain the existence of our universe out of this number of universes. And an appeal to science fiction, such as an infinite multiverse or some sort of multiverse, is fantasy and not evidence and not provable. So why would you believe it? Um, okay, well, I hope you learned something. Um, Next time, I'm going to review chapter 18 of my book, which is entitled Divine Simplicity and Non-Temporal Causation. All right, take care, everybody.